These are some data from one of your classmates, and I'll do the first one as an example. This one is magnesium sulfate. So you know how to get this from the lab, the online lab, and you know how to get this from the online lab. You know how to get this from the online lab. Some people had questions about this. This formula of anhydrous salt, that's just a formula for this thing, magnesium sulfate. For the next one, it would be this thing, the formula for copper 2 chloride, the formula for cobalt 2 chloride, nickel 2 chloride, copper 2 sulfate. You just write the formula there. Anhydrous means without the water. So in this lab, you find out how many water molecules are associated with each of these formula units, with each magnesium sulfate unit, and etc. So that formula goes there. So I'll put magnesium sulfate, since that's what I'm doing. I put MgSO4 there. That's my handwriting. Formula weight of anhydrous salt. In the class, in second period, some people were asking about this. Sorry, I made a mistake. I told you that this was a typo and that the formula shouldn't be there. In fact, formula should be there. This is not the only typo here is that the an is separate from hydrous. So it's not formula weight of hydrous salt. It's formula weight of anhydrous salt. And so one of your classmates in second period correctly identified that this just means the molar mass of this item. So that's magnesium on the periodic table, something like this mass, this many grams per mole, plus sulfur on the periodic table, something like this many grams per mole, plus 4 of these oxygens on the periodic table, something like this many grams per mole, but 4 of them. Sorry about the handwriting there. That number comes out to something like this, 120.369 grams per mole. That's grams per mole. So that's grams per mole there. And then formula weight of water. You know water is H2O, and the formula weight there is just 2 H's and 1 O on the periodic table. So that comes out to about 18.015. That's also grams per mole there. Grams per mole. So that's how to do table 1. Just get the rest of the data if you didn't do so already in class using the online lab. This thing. And then fill out the table as I did the first example. Now, sometimes it's kind of tricky. One of you found in class that it's hard to use the spatula, this spatula thing, to get a sample of some of these items and to put that sample inside the crucible. And the reason why sometimes that's hard is because the jar is in the way. If you have the jar on the table, move the jar to the side if you're having trouble dropping sample using the spatula into the crucible. So the situation would be like this. You would have the crucible here. You click on the crucible and the lid is off, and then if the jar is right next to it, it's hard to move sample from the jar to the crucible using the spatula if the jar is in the way. So you can just move the jar to the side and that will help you out. All right. And some people had questions about data table 2. The instructions for data table 2 are on the worksheet, and I'll just go through an example with you. Let's see. Weight of anhydrous salt in grams. So now weight 1 equals C minus A. By C, she means this C right here. By A, she means this A right here. So the weight that goes in here is this number minus this number for the first row. So let me do that. This number, 10.790, minus this number, 10.502. These are in grams. And so for that, on the calculator, I get about 0.288 grams. I haven't put the units in here, but you should probably be careful to do that because units are important. Grams. That's grams. That's grams. That's grams. That's grams. And this is going to be not grams. This is going to be grams. Okay. So, what about this one? Weight 1 divided by formula weight. So formula weight was here. This was the formula weight, grams per mole. Can you see the mouse icon moving up there? This was the formula weight. So the number of moles of anhydrous salt is the weight 1 minus divided by formula weight. Here's weight 1, so 0.288 grams divided by 120.369 grams per mole. And that's going to give you this many moles. So that was moles. So you have to label it as moles. The next one, number of grams of water in grams. All right, so it's in grams, that's the units, so that's good. That's weight 2, which equals C minus B. This is C here, see the mouse icon moving? Minus B, this is B here. So it's this number, 10.790 minus 11.104. Okay, and that's 0.314 on my calculator. Yeah. And that has to be in grams, so make sure my G is there. Moles of water in hydrate sample, that's weight 2 divided by formula weight of water. Formula weight of water is over here, remember, the 18 grams per mole. So weight 2, this is weight 2 over here, 0.314, so it's 0.314 divided by 18.015. So for that I get 0.0174, and that's moles. Make sure I label that as moles. Okay. Now, how many moles of water are associated with 1 mole of the anhydrous salt? To get that, you look on the front of the worksheet, and there are instructions there what to divide. You're going to divide the number of moles of water you have by the number of moles of anhydrous salt you have, and that's going to tell you how many moles of water are associated with every mole of salt, or even how many molecules of water are associated with every formula unit of salt. So this is 0.0174 divided by 0.00239. And you get 7.2 something, but remember, on the front of this worksheet, Sabrina says you can't have a fraction of a molecule of water. So she wants you to round this to the nearest whole number, and that's 7. So this 7 moles of water means that for every formula unit of magnesium sulfate, there are 7 molecules of water stuck to it. And those 7 molecules of water are necessary for the crystal structure of magnesium sulfate. The empirical formula for the hydrate, this is just done with a dot. Here, I'll show you. MgSO4 dot 7H2O. Is that illegible? Here, let me do that down here for you at the bottom here. MgSO4. I'll raise this up so it's more visible after I finish writing it. Dot 7H2O. So you notice, I'll raise this up for you now. Here it is. What I have written here, and it's a little illegible there, sorry, is MgSO4 dot 7H2O. MgSO4 was the formula of the anhydrous salt. The dot indicates that the following number of water molecules are associated with every formula unit of this salt. And then the 7 is what you wrote here. There are 7 molecules of water for every formula unit of MgSO4, or 7 moles of water for every mole of MgSO4. And the H2O indicates what there are 7 of, H2O. Okay? That's the empirical formula for the hydrate. Sorry about the confusion